Hi, I'm Sean. I'm a H1 maths student and I'm studying maths in college. And I'm here to help you get through your Leaving Cert maths questions. So let's get into it. Okay, so here's our question. We're given this function f of x is equal to 2x cubed plus 5x squared minus 4x minus 3, where x is a real number, and we're asked to show that for part A, that x is equal to minus 3 is a root of f of x, and we've got to find the two other roots as well. Okay, so the first step is going to be really straightforward, and that's just going to be to plug in x is equal to minus 3 and ensure that that will equal 0. So that is going to look like this. And obviously if this does in fact equal 0, then we can say definitively that x is equal to minus 3 is in fact a root. So when we simplify it out, we're just going to get these set of numbers, and it does in fact equal 0 when you add everything up. So that is the first step done. And now in order to find the other two roots, like they've asked us to, we're going to now say that x plus 3 is a factor, because x is equal to minus 3 as a root implies that x plus 3 is a factor of f of x, that equation we got in the question. And so to find the other two roots, we're simply going to divide in our factor x plus 3, and then hopefully get out a quadratic that we can then either factorize or put in the minus b formula to find the other two roots. And that's what we're going to do. So here's our long division. We're just going to divide x into 2x cubed, which will obviously give us 2x squared, and now we're going to multiply that down by x plus 3. And when we take that away, what we're going to be left with is minus x squared. So now we have x into minus x squared, which is just minus x. We're going to bring down our minus 4x, and then multiply minus x by x plus 3 once again, and take it away. And what we're going to find is that what we're left with is just minus x. X into minus x is going to give us minus 1. Minus 1 by x plus 3. We're going to do that in a sec. We just forgot to bring down our minus 3 there. So minus 1 by x plus 3 will give us minus x minus 3, which will mean, of course, that our remainder is equal to 0. And we're left with this nice quadratic on the top of 2x squared minus x minus 1. So then we have f of x now as two separate factors, but obviously because one of them is quadratic, we can simplify that further and just factorize that and find finally the two roots we're looking for. So our first step is going to be to recognize that in our first bracket we're going to have 2x as well as x in our second, because this is the only way we're going to achieve the 2x squared. And the only factors of minus 1 are going to be minus 1 and plus 1. So just need to figure out the order. In order to get minus x, we're going to have 2x on the outside along with minus 1 on this side, which means that plus 1 will be in here. And then we have minus 2x plus x, which will give us this minus x, which is generally how I do it at least. Of course, if you want to use the minus b formula, that's perfectly okay. So based on those two factors, our roots are going to be x is equal to minus a half and x is equal to 1. And it's crucial that you write this down, because it did ask us for the roots in the question, not just the factors. But might as well add x is equal to minus 3 to that list. So those are our roots, and that is it for part A. And it's very common you're going to get a question like this in paper 1, where you have one factor and you're asked to find the other factors, basically using long division, and then just solving a standard quadratic, and that's worth 15 marks. So part B tells us to find the coordinates of the local maximum and the local minimum point of the function f we're given in part A. So we have f of x, and if you're thinking you're going to have to differentiate it here, you're definitely along the right track here, because anytime they give you the words maximum and minimum, and there's a function involved or a graph involved or anything like that, generally it's going to involve differentiation. And in this case, because we have a cubic, now we know that we have a minimum and a maximum, because cubics are generally sort of like that shape. So that would yield one local maximum and one local minimum, just as an example. And the reason it's a local maximum is because at all points close to the maximum, and the maximum is the largest point. So it's not necessarily the largest point that our cubic will ever take. It's just the only point before and after which there's a decrease in the value of f of x. And the opposite can be said of the minimum. So it's the smallest point in its general proximity. So what we're going to do is just differentiate f of x to get f dash x. And once we do that, we're going to be looking for where that equals 0, because as I'm sure you know by now, at a maxima or minima, the rate of change of the function is equal to 0, because the slope would be sort of a flat line. It's just a horizontal line. So now differentiating f of x, one term at a time. Of course, if you need to use log tables for this to look for the rules, you can. But I'd say most you probably don't need to. We're just going to bring down the 3 and get a 6x squared once we reduce the power. Plus bring down our 2 at 10x, once again reducing the power. Minus 4x is going to turn into minus 4. And our minus 3 is going to disappear. So once again we have a quadratic equal to 0, which we can then factorize in order to find our x values we need. So the first thing we can do here, because we've got an equation with 0 on the right hand side, is just divide across by 2, which won't change anything. It's just making it a bit easier to factorize. But of course that is optional. So now in our first bracket we're going to have 3x and x, because there's only two factors of 3 times x to be squared, where we have an x in two different brackets. And now we're just going to figure out which factors of minus 2 we need in which bracket. So we need it to add up to 5x. So our factors of minus 2 are just going to be either minus 2 and 1 or minus 1 and 2. In this case we need minus 1 and 2, because the only way to get to 5x would be to say that we have 3x by 2. So we'll put our plus 2 there and we have our minus 1 here. So now we have 6x minus x, which is equal to plus 5x, which we have in the question, and those are our factors. So that means that our values of x are x equal to a third and x is equal to minus 2, and those are the x coordinates of the maximum and the minimum. But of course we're not finished, because we don't actually know based on this which is the maximum and which is the minimum, and to do that we're going to have to figure out the y coordinates, which correspond to these x coordinates. And to do that we're just going to plug them back in to the original f of x. So what you'll find if you plug in a 1/3 is that the value you get out is minus 100 over 27. And again, that's just plugging in 1/3 wherever you have an x up here in the original f of x. So that will give us our first coordinate. And doing the same thing again for f of minus 2, you're going to get that the value is 9. And that's going to give us our second coordinate. And because 9 exceeds minus 100 over 27, our max is going to be minus 2, 9, and our minimum is going to be at 1/3 and minus 100 over 27. And again, we can tell that based on the value of the y coordinate of our maximum and minimum respectively, because obviously the max is going to be further up the graph than the minimum. So there are the coordinates of our maximum and our minimum. And that's it for part B. So that's a good question, test your knowledge of maximums and minimums and how to find them, and that is worth 5 marks. So part C gives us f of x plus a, tells us that a is a constant and has only one real root, and we're asked to find the range of possible values of a. So there might be something to be done here with a certain formula, like b squared minus 4ac is equal to 0, but I just like to solve this based on a sort of common sense. So if we just sketch any cubic function which crosses the axis 3 times, as we know that f of x does, because we found that the minimum lies below the x-axis and the maximum lies above the x-axis. So in order to convert this to a function which only has one real root, or in other words only crosses the axis once, what we're going to have to do is just shift the whole function either down, so that sort of this whole portion would lie below the axis. Alternatively, I should say, move it up so that this sort of whole portion here would in fact never cross the axis either. So really what all we have to do is move the function up or down in proportion to how far away it is from the axis at its minimum and also at its maximum. And as I say, this is true for any cubic function which crosses the axis 3 times, and not necessarily f of x, although this can also be applied to f of x. So the only thing left to figure out is exactly how much we've got to move it. And as you may have guessed, it's based on our knowledge in part B, where we found the maximum and the minimum. And the amount we've basically got to move it by is ever so slightly more than the y coordinate of our 2 points that represent the maximum and minimum. So in order to move it down, we would have to decrease it by at least 9, and in order to move it up enough, we would have to increase it by at least 100 over 27. So therefore our answer is just a is greater than 100 over 27, or a is less than minus 9, or as we said, a needs to be increased by more than 100 over 27, or decreased by more than minus 9, or decreased by more than 9 I should say, which would mean moving it more than minus 9. And so that's kind of a different sort of part C. It's definitely going to test your understanding of how functions work, and particularly how they move, because as we now know, when you increase or decrease the constant on the end of a cubic, it's going to change where the function lies sort of with regards to its height or its proximity to the x-axis. And I hope that made sense, and that's going to be worth 5 marks. And that is it for this question. I hope you enjoyed the video. If you did, there's going to be other similar videos in the description, as well as some other helpful resources for practicing cubics and factorization in general, and maybe also test your knowledge of graphs. So that is it for this video, and I'll see you next time.